Welcome to Complementary Angles, a podcast about current events in mathematics and ways that we can support you in the classroom and beyond.
All right, we're going to start with quick introductions because you may not know us. This may be your first time listening or watching. My name is Kelsie Johnson Lumadue, and I'm an instructional content coach here at ESC Region 11. I focus on early childhood learning and elementary math.
Hi, my name's David Henson. I focus on non-elementary mathematics. Why are you laughing? I'm secondary mathematics here at Region 11, and I focus on everybody over 4 foot tall.
I am 64 inches tall. Thank you very much. I claim all of those inches. All right, so today on Complementary Angles, we want to talk a little bit about building a language-rich mathematics classroom, what that looks like, and a couple of different ways that you might embed these math language routines to help your classroom just dig a little deeper into the math topics that are in front of them.
Getting kids to talk is actually a very powerful way for them to express understanding and for teachers to understand where the kids are at. Gone are the days of they sit, we talk, and they listen. Mm-hmm. The more conversations we can foster, the more learning that we can have evidence of, and more importantly, that can happen.
Yeah, like when you walk into a classroom for coaching, isn't it a little weird when it's like totally silent?
I like a classroom where it's rich and the kids are engaged, and part of that engagement is the ability to tell me what they're learning.
Mm-hmm, mm-hmm. And talk with their peers, right? Like the talking is actually a vital piece of us checking in with students and them building their own oral language skills.
And quite frankly, I'm a secondary guy, so talking was probably happening anyway. I'm just happy it was mathematics.
Mm-hmm, mm-hmm. Got it. As long as it's like relatively on topic, we're happy?
That was my job, yes.
Okay, yes. Yeah. Good job. You did it. Okay, so for this work, this topic of mathematics language routines, one of the research articles that we found a couple of months ago that we've really kind of rooted in as a mentor text for us, it came out of Stanford's Graduate School of Education in 2017, and if you want to look it up for yourself, it's actually called Principles for the Design of Mathematics Curricula, Promoting Language and Content Development. I love a good long title.
Trust me, we're going to put a link to that in the content stuff below, but before you go ahead and try to type that up, don't let me do the typing.
We'll link to it below, and it really digs deep into just kind of the purpose behind building math language routines, solid design principles whenever you're thinking about choosing a math language routine, and then several different examples of.
And the one thing I liked about it too was like it gives you reasons why you would do the different routines, because like everybody has one or two good things that they like to do, but when would be the best and most optimal time to use it as when working with students on a concept.
Yep. So that's a fantastic resource to dig into if you want to know more about math language routines. So for the first angle of these complementary angles, I'll start by describing a math language routine called 3 reads. Okay. What I love about 3 reads is we can use it in math in a strategic way, and it's applied across many different content areas. So you can use this if you're a math teacher, of course, but if you're a self-contained elementary teacher, you could also try this across many different content areas. So with 3 reads, students are going to read a math problem 3 times. Duh. Okay, the first time they read it, it's just for comprehension, right? Do they understand the text? That's a key piece to understanding the problem. The second time they read, they are going to be analyzing pieces of the problem. So I don't want the analysis part to be too cookie cutter. So it's not like, oh, when you analyze, you're going to circle all the numbers or circle the keywords, underline the keywords. No, because actually that can backfire really quickly on students. So putting on that critical thinking hat and really trying to visualize and figure out, okay, what's really happening here? Depending on the problem, if there's a graph involved or something like that, they might do a little bit of labeling. That's part of the analysis. And then the third read, they are going to be brainstorming possible mathematical solutions. And that part should definitely happen with at least another student. So at least a pair, if not a group of students. That's kind of when they come together, read it one more time, and then talk about what are those solutions that could help them figure out the problem. So have you used that one before? What are your thoughts on that?
Yes, I've used a slightly different version of it, and I think 3 reads actually as a strategy is an outstanding way to empower students to be able to go into word problems and know what to do when they don't know what to do. It's a frustration for me when I see students who get to word problems and they just shut down immediately.
Right.
So giving them that toolkit so that they can break apart the problem systematically so that they can at least get into a closer pathway to getting the correct answer is a powerful tool for kiddos.
So kind of like a structure to fall back on, like, okay, this first time I read it, I may not fully understand it, but I have 2 more chances to read it to wrap my head around it.
And the thing I like about it too is I'm looking for information particular to the read. So I'm not going to be that number plucker that's just going to go peel out all those numbers and then have no real concept of what operations to use, what it's asking for. How many times have you had kids that they do the math right, but they answer the wrong question?
Right.
So 3 reads is definitely a powerful tool for kiddos to actually break apart the problem, but in a scalable form.
Definitely.
So I have a different angle to you.
Okay. What is it?
For me, I like, from that article in the category of maximizing meta-awareness, I like co-craft situations. And the particular way I like to do that is actually slow reveal graphs. Slow reveal graphs is an opportunity for kids to analyze a graph before they see the problem. It goes in steps. The very first step is I take a graph, I strip off the title, I strip off the axes, what they're measuring, and I strip off even the units, and I just give them the picture and say, tell me a story. Create a situation that would explain this. And then layer by layer, I will add in information and ask them, does this fit your story? Can you fix your story with the new information? When we get to the title and I give it to them and I'll ask them the question, well, how'd you do? And the kids are like, I was totally off, but they're still engaged. For me, engagement is about keeping them into the problem. And for those kids that have math anxiety, and math anxiety is real, if not, go ask every other principal who ever walks into your math class and says, offhand comment, I'm not good at math anyway, and then walks out the door and you're like, oh, thank you, sir. But understand, those kids are still living in opinions and creativity. I'm asking them to use high-level Bloom's taxonomy strategies in analyzing a problem long before I ever get to A, B, C, or D. So as we get into there, we get them going, they definitely have an intrinsic understanding of what the graph is. So when they get to the actual problem presented, they are now empowered, and they also have a great strategy to understand. And if they get it wrong, they have the tools in place to figure out what part they missed and how they can fix it. Now, low key, let's be honest, we all know that there are kids that they can complete an entire assignment by the time I've passed it out to the entire class. Some people call them high flyers. I know I like to call them abstract thinkers, or to be honest, Key is probably their middle name, because if they ever get a question wrong on a test, I'm going to check my key to see if it was wrong, to be honest. So those are the kids that I have a problem with, of shooting out the answer before I can get it. So in a discussion, they almost train wreck it. In this, they can't get the answer yet. So they are on equal footing with every child in the room. And that is a powerful thing. So if you're a kiddo who feels less than capable in math, you're on the same footing as the kid that you assume is the smartest. And that's the reason why I like slow reveal graphs.
So it sounds like slow reveal graphs also kind of taps into those kids that need that creativity. They need the flexibility to feel like, okay, I've got this, I know something here. And this can be like a bar graph or a line graph, any type of graph?
Yes, bivariate or univariate. It could be a traditional scatter plot, line graph, pie graph. Anything where the student has to have the opportunity to analyze.
I love that. Okay, cool. I definitely want to use that soon. So let's go back a little bit to co-craft situations. So co-craft in the name suggests that we're kind of bringing students along with us to create a math situation. Is that right?
Yes.
Okay, fantastic. Is there other ways that you know of besides slow reveal graphs, or is that like your favorite way?
There's other ways. Co-craft situation is we would give them particularly a naked math problem and say, create a situation that would explain this relationship. There's also co-craft questions where we go the other way. And so instead of creating a situation, we give them a situation and say, what could I ask out of this? 3 reads, numberless word problems are some great examples for that.
Okay, fantastic. Okay, so we've talked a little bit about a couple of different ways to build in these math language routines. What do we think is the biggest benefit to students, I guess, whenever we implement these habits of increasing conversation?
Engagement. I honestly think that if a student is emotionally invested in what's going on in the class, their performance is going to improve. If they feel that their feedback is not going to be glossed over, if they feel they're on the same footing as everyone else, they'll stay engaged. There's plenty of time for them to figure out that they're having some difficulty in math, but I don't want them to have it like at the very beginning. So I want my students to feel invested, and somewhere along the way, they're going to figure out some things. And quite frankly, it's a lot more fun.
Oh, yeah. It's more fun. It builds that engagement, gives everybody a little bit of confidence, puts them on the same playing field. I love all of those things. It also definitely helps our students that are coming with, if English is not their first language or they're learning in a language that is different from what's spoken at home, it kind of gives them some structure to come into the conversation.
And if you're thinking about your ELPs, one of the biggest things they need is an opportunity to use the language and academic vocabulary in an appropriate situation. So I give students a chance to explain things,
Right.
to use that academic vocabulary that I've spent so much time working on, but I never manufacture great opportunities for them to give it back to me, other than question 4 on the test.
Right. And it's different than just like, oh, turn and talk to your neighbor about this problem. That's really broad. What these routines give us and our students is just a little bit of structure so that they have that support and we know targeted what to listen to whenever we're kind of tracking and watching for the power zone.
And it really gives us an opportunity to sequence those events so that I can tell a story with what they're giving me. So I think all of these routines are really good, but I like slow reveal graphs.
Yes, that is, I can tell, one of your favorites. All right, do we have a challenge for this week?
Our challenge is for you. We want you to try one of these 2 activities or routines in your classroom.
Yes, I love that.
They're not hard to do. We'll have, if you check the links below, we're going to have some information for you to see some examples of it. I know we have some examples in secondary mathematics for slow reveal graphs, and I know that 3 Reads has an abundance of materials for both secondary and elementary. So this is on you. Your turn to try one of these challenges because you got the kiddos.
Right, and try one of these that we talked about, or if you read the article and find another one, or just research a different math language routine, we would love to hear how you're building those critical conversations in your classrooms.